So one of our participants who asked the question then, so regarding what are the possible applications of machine learning in crop production. So we made a promise that we are going to look into it, and considering the importance of this, how important this topic is for everybody. So we said, okay, we're going to have a couple of series on the possible application of machine learning in crop production. We don't need to be a farmer before we can actually lay a hand to this kind of very important topic. And that is, we can see, okay, how can we assist farmers around us if we are not one? So, because if you have an enabling environment, my own position as least is that at least the little you can feed yourself around your compound, around there, and also provide the necessary guide and the technological insight that you might be able to provide to those people who are into this very important field of endeavor, that humanity without food, so we can hardly do anything. So if you have the money, you don't have the food to buy, for sure, there's going to be a big problem. So today we are going to be looking into some of the possible application of machine learning in crop production, and then how can we take advantage of the latest technology in artificial intelligence and machine learning towards getting improved yield. So as we know that agriculture is an age-long means of livelihood for the entire populace, so alternative to it is still being found. So it's been a very, very important age-long means of livelihood to millions, and several millions are being fed globally. So when the global demand on agricultural products continue to increase over the years, so which has actually necessitated trying to come up with some yield that can actually increase, produce faster. People tend to go for, okay, we want the yield that can produce faster. However, when you try to get shortcuts to the production process, so there's going to be negative side effect, the health concern. Some of the modified products actually later found out that they are no more having the kind of nutritious value they were having before the modification. So rather than going in this route of looking for how to make food faster in the product, trying to make plant produce more than they have the capability by way of modifying their genetic makeups, can we actually deploy machine learning to actually see how can we integrate data-aware decision-making that can actually fast-track, prevent damages, lead to more improved agricultural yield production without necessarily considering the negative aspect, because when we implement technology, we have to always look at the negative aspect. Is very important. So, but often than not, so we focus on, we just want to get as much food out as possible, but then do we consider the negative aspect of it? So we'll be looking into it to see, okay, how can we advance technology, especially the machine learning that has been changing the face of the way we do things in the world today. So given the technological advancements, so in farming, so we are not talking of precision farming actually. So how can machine learning and AI be leveraged to increase the efficiency and accuracy in decision making? Because the right decision is very important, while also reducing the risk. Very important. You have to reduce the risk, both the medical risk, the financial risk, and the cost that is associated with agricultural operations. So information, as we know, is life. So having the needed information at the right time can make a very big difference. And I think this is where AI and machine learning actually is a very, very important topic that we need to look into in the case of crop production. And you don't need to be a crop production expert before you can lay your helping hand on this. So everybody can render help, trying to see what kind of technology can we deploy that can assist farmers to be able to take advantage of this unique capability. So we're making a case for predictive machine learning solution at the beginning. There are so many other areas or ways we can implement AI and machine learning. But for the start, we are making a case for predictive machine learning solution. Now, so a predictive machine learning solution for crop production can take several forms. For example, so using AI and ML involve leveraging data-driven insight. When we say a predictive solution for crop production using ML and AI involve leveraging data-driven insights. Data-driven. So, and data is in the past. So we have an idea of what has happened in the past. Can we be able to take advantage of this past data set? And the data is always available, maybe wasting away, or people are not even paying attention to it. And this data insight actually can lead to optimization of farming practices and enhance yields. Especially this is becoming very important as agricultural practice faces challenges such as unpredictable weather. So in the past, we used to have very stable weather. We know when the rain is going to start and when it's likely going to stop. But these days, things are changing rapidly. Sometimes the rainfall will fall for the first week and then people start planting and then it stops. So can we have an insight what are likely going to be the possibility? So we need to invest in the weather forecasting regarding the agricultural practices. Also pest outbreak. So can we also have an idea of pest outbreak using a predictive solution? The need for efficient resource management. Little management we're having, how can we effectively and efficiently manage them? So in this regard, we made a case that a predictive solution for crop production using AI machine learning aims to address these challenges by analyzing historical data. So analyzing historical data and the real-time data in order to make informed decisions, very important, informed decision, not just decision based on what we used to know. Things are changing. When people are in the crop production training institute or universities or polytechnic or wherever, school of agriculture, what you are taught there was based on the reality of weather, but now things are changing. So we need to make informed decision, not just, it's not an issue of memorizing what you knew before. This is how to do it. We have to look at the current state of things, the weather situation. So we need to make informed decision about planting. If you are aware that, okay, the prediction already says that there's going to be rain for 1 month and there's going to be a stoppage of like 2 months or 3 months, then you can be able to take a decision that means that, okay, maybe I need to delay the planting, or if I have to plant, then we have to make provision for irrigation. So that what you spend a lot of money to purchase this material, weeding and the likes, and then after planting, the rain stop, nothing to do. We keep crying, oh, the rain has stopped, and there's nothing we can do about it. So in this sense, if we have the information ahead of time, predictive solution can let us have an idea of, okay, how is the weather going to be in this coming season? So that we can be able to, okay, we need to make provision for irrigation, or we need to delay the planting to avoid the loss. So, and the decision could be about planting, even the irrigation we have to carry out, what of pest control, even harvesting. When do we harvest? Data, historical data can be able to tell us, oh, if you delay your harvest, something might go wrong. And what might go wrong? So all these things can be taken care of by predictive solution towards achieving better crop production. Now, so moving further, we say these are possible components, predictive solution for crop production. These are possible components to look at for. Data collection is very, very important. See, data collection is very, very important. So we have to gather data from various sources, including either weather patterns, soil health, crop history, what is the history of crop you are trying to actually plant. So, and of course, satellite imagery is another thing to be able to know terrain and things that might get wrong, or the case may be. So gathering data is very, very important. And it's not also interview, I mentioned this last time also, interview-based data is very important. Let's go to the practitioner, talk to them. Because you might not be able to deploy the sensor technology immediately. Can we have a kind of interview-based data collection? So, which we are going to talk about this toward the end of the class today. One of our members here has volunteered actually to create a kind of Google form where people that are interested in this kind of area of research can team up together and they can come up with data collection from farmers towards starting a kind of predictive solution that can assist either in yield production, prediction, or in the prediction of when to start or when not to start and the different type of plants that we have. So when we talk of data set, so gone are the days that we have to keep looking for data, the data is not available. You can build your own database easily. Just create Google form, let people talk to people who are into this practice of crop production, and then they can be able to bring out the best we can have. Now, so this is the first component, which is very important, data collection, because let the data speak. Always remember that without data set, then predictive solution will be just impossible. Then the next is to look at the machine learning modeling, where you can develop model to predict crop yields. So based on the historical data set, so you can ask a couple of questions. What is the size of your farm? Last time you did this particular, the same product, maybe the same plant, maybe it is cereal or it's vegetable or it is tuber-based. So there are a lot of questions, basic questions you can ask from the farmers. They might not pay attention to it, but you know the power of data. You know that if we have data, this can actually assist us in taking decisions in subsequent years. So we can gather some of these data sets. Also, environmental factor also need to be looked into, and other agronomic practices. So in this sense, there are many predictive solutions we can look into, but the first one is you might have to use classification model for pest detection. Want to detect if there's going to be pest or not, and then which kind of pest. Also, you can also be able to use regression model to predict yield production. So if you have this particular size of land, if you do this, did you use fertilizer? So historical data set, gather them together. Let's see which of the attributes are more important to be able to estimate the yield that can come from a particular acre of land or a particular size of land or farm. So you have to target it. Sometimes it could be multi-stage solution, as we have also discussed before. You might have to start with classification, and then later, you move to prediction. Then also the possibility of using IoT sensors. So you need to, sometimes we might have to implement sensors in the field to collect real-time data on soil moisture, temperature, and other relevant parameters. So we see how we can implement we can make use of this kind of sensor system as we move on later on. So because this could make a lot of impact. So there's some kind of soil, people are used to the kind of irrigation before, but now they moved to a totally new environment where the attribute of the soil is totally different. But people keep using the same experience they had in the previous farm to farm in the new location. This can be a very mistaken decision. See, each land have their own characteristics. What is moisture retention capacity of the particular soil? These are things that are very important. Sometimes you think, okay, once I send the irrigation of like maybe 100 liters of water in the morning, it is okay. In the evening, but you get another soil that has totally different moisture retaining capability. But then you are thinking the one you were using before is going to work. So you keep sending the same size of water you have been using before. By the time the harvest, you start noticing that, oh, this plant is not responding. This thing is not responding, but I'm supplying the same liters of water we have been using before every year. But they didn't pay attention to the fact that there are totally different characteristics of that soil. By the time they realize it will be too late. Those plants will struggle to grow, struggle to produce, but you cannot expect such plant that doesn't get the needed amount of water, other nutrients to produce as they used to be. So these are information that are very important that need to be handy for people as they move from one side to the other. Also in crop rotation practice, whereby you want to plant one here, plant another one here, predictive solution also can help us in guiding, provided the needed guide to farmers towards being able to take informed decision at the appropriate time. So that is under IoT sensors. That is, IoT sensor is the Internet of Things. Some of the gadgets we are using will be integrated with data collection capability. Some of them can even have the inbuilt predictive solution that can determine even the planting. So we're going to look into that later on. So when we go to the state of the art, some of the crop production automation. Also, remote sensing, that is trying to utilize satellite or drone imagery for crop monitoring. So we need to monitor the crop, disease detection, and to assess overall field health. How is the field going? I see disease detection. It's not just, we want to also predict, is there going to be disease outbreak in this particular farm? It is possible. We don't wait for the disease to spread before then we start treating it. Can we actually predict ahead that there's going to be some pest outbreak? Then we can make provision for how to solve it, how to prevent it. So, but however, we do reactionary thing because we don't know. Sometimes somebody just visit the farm and found out that, oh, there's problem here. Can we actually envisage so that we have what we call preemptive? We have a preemptive system. Before the problem happens, you already have a system that can alert you that this kind of thing might happen. And it is possible these days with the necessary machine learning predictive solution so that you'll be able to take preventive measures to actually prevent the problem from coming up. And then in totality, once we have all these particular systems built, then we can have an integrated decision support system. So, which is actually an integrated predictive models, combining fusion of different sensor data into what we call decision support system. As the name goes, decision support system is something that supports the decision-making process of an organization, but this time around of the farmers. They provide actionable insights. Actionable insight. What are the actions that need to be taken? You are not just taking decisions based on what you knew before. No, based on the reality of what might happen in your farm because of the huge predictive solution you have actually invested in. So the farmers can have access to this. So a user-friendly dashboard that is accessible. A dashboard is a kind of a summarized, a system that has a summarized presentation of the most important KPIs, key performance indicator that is going on, that the manager or the person in charge, the farmer can always, just looking at the dashboard, you can see, oh, something is going to go wrong here. Oh, something is going to go wrong in the other side of the farm. So they can quickly take informed decision and then harass the situation and prevent the negative prediction from coming to pass. Because the use of predictive solution is for you to have an idea that something might go wrong. It's not that you are wishing that something will go wrong, no. So once you, because there are different types of analytics. So we have the one we call the descriptive analytics. This one is, you cannot do anything about this. In descriptive analytics, what has happened. You gather the data and try to understand what has happened. Why the yield was slow, what was. Then the next one after the descriptive analytics, you move to the second one, which we call it the diagnostic analytics. Diagnostic analytics is trying to now find out, okay, what was responsible for the kind of data set we had? Why did they experience the low yield? The pest suddenly appear on the farm. What went wrong? That is diagnostic analytics. So we're trying to understand what could have been responsible for it. And then we move to predictive analytics. See, these are in the past tense and try to understand what has happened in the past. So predictive now is about insight, future. We look futuristic. Then what could go wrong? We don't want to start asking questions. Oh, why this data? What went wrong? Why was it like this? Now we want to have a proactive system, a predictive solution. That once the predictive solution gives its own verdict, oh, this thing might go wrong. There could be an outbreak of pest in so farm. Then we now run the fourth type of the analytics, which is called prescriptive analytics. This is where you're now trying to say, okay, how can we make the prediction to come to pass? If it is a positive prediction, you have just predicted that this farm is going to have high yield, then prescriptive analytics will take you further that, okay, what can we do to ensure that the prediction will come to pass? It will be a reality. This is prescriptive analytics. So what can you do? What optimization can you do? What input can you supply to your farm to ensure that this good prediction will come to pass, that the yield of the crop are going to be very, very fantastic? However, when you have negative prediction, there's no good to be low yield. The prescriptive analytics also will still come back and then help you to see, okay, how can we prevent this negative prediction from coming to pass? What can we do to prevent this very scary predictive outcome from the machine learning models? You can see that either negative prediction or positive prediction, there's always room for you to work hard to make the positive one come while you try to work hard to prevent it from coming. This is actually the essence of the predictive outcome. It's not just to predict and scare people. No, we want to have an idea of what could go wrong based on the data set we had in the past, and then appropriate decision could be taken. So a well-developed, user-friendly dashboard that is accessible to farmers, providing real-time insights and recommendation for optimal planting times. Maybe you need to change your planting times based on the predictive solution. Irrigation schedule also might need to be changed because the land you just moved to is totally different from the one you were doing before. You need to change the pattern of your irrigation and the amount of water supply because of the characteristics of the sand. And also the pest control measures decisions need to be taken in an informed manner based on the reality of data that is available. So these are some of the stuff to look into when we're talking of having predictive solution for crop production as possible components. Now, expected result, if you implement some of these predictive solutions, so it is expected that farmers should experience significant increase in the crop yields due to more informed decision making. So resource usage, of course, including water, pesticide, will be optimized, thereby saving costs and environmental benefits. Sometimes you pump in too much water to the field in irrigation, leading to waterlog, and some plants don't need it because the retentive capacity of that land is different from the one you are used to before. Before you pump like 100 liters, at least 50 liters of it will stay with the plant, or that will go down the soil. But now you have a totally new environment. If you don't have an idea that this soil is having a different kind of characteristics, then you might have to do trial and error for the first 2 years before you get to know it. However, we have it with adequately well-developed predictive solution, it can tell you that no, this soil is having a totally different capability. And I think in this sense, a lot of IoT devices need to be deployed to our farmers to help them see if people want to build a house, people carry out a lot of soil tests to see if this soil can support the house, if the soil can do this. If you want to do oil and gas, you want to dig a well for oil, you have to do a lot of investigation on the land. Is this soil, which kind of characteristic is this soil having? Is it going to support what you want to do? Unfortunately, our farmers have been left to them to do trial and error. Sometimes they get it, sometimes they don't get it. So I believe with this kind of technology, with support from appropriate bodies and organizations and NGOs, to me, these are some of the very important things that NGOs should be up to and supporting towards increasing food production for the populace. Of course, early detection of pest outbreaks allow for targeted and timely interventions, thereby minimizing crop losses, so which is very important. So we can early detect what we shall call preemptive detection of pest. So pest outbreak. So that you are aware that it's going to come, then you can start the preventive measure so that it doesn't come to pass, thereby minimizing crop destruction and the losses, and then thereby increasing yield. And of course, improve sustainability practices and reduce environmental impact through precise resource management. It's also very, very important expected outcome when we implement predictive solutions at appropriate level that we may deem fit. So these are some of the predictive solutions we can look into. There are so many of them, especially the yield production, so which is going to be one of our starting point in a group that's going to be created for people who might be interested in this kind of a research idea. So because of our time, we are going to give room for this, a very important topic that affects everybody. So we cannot finish the exposition of the AI intervention system for crop production. So we're going to be continuing with others application area that we might have to look at the other time. So, however, before we move for the other one, hopefully this time, for example, crop monitoring is another application area to look into, crop monitoring and disease detection. So where a lot of technological base will be predictive, some of them will be regression, classification, or as the case may be, and they will involve a lot of drone and IoT devices that can monitor the system, which, if well put into use, can actually preemptively detect if something will go wrong in the farm, rather than waiting for it to go wrong and we start looking for solution. So we can detect it early enough so that we can be able to deploy preventive measures. If something is detected early before it spreads, then you can minimize the damage to the farm product that we can actually have. So, and there are going to be other areas that we're going to look at, hopefully, in our next session that will still be dedicated to crop monitoring and disease. Crop production, which has several aspects we're going to look into. So machine learning algorithm we use to estimate the crop yields, diagnose plant diseases. So which is where we are going to talk about our immediate plan for now for people who might be interested in this area. We want to see how we can use a machine learning algorithm to estimate crop yields, the amount of yield you can get based on which characteristic, based on which attribute, and also diagnose plant disease and pest, and then optimize the plant growth accordingly. So, and then towards the end of the class, so like I said, we made clear there's a kind of questionnaire that's going to be produced. One of our members volunteered to work on that. So to the questionnaire, so please, we're going to be creating a group, which we're going to call a crop monitoring, machine learning for crop monitoring research, or machine learning application to cross monitoring or crop production. So we'll be creating the groups. Those that might be interested in working with us in that group can also join the group. It will be made available in our usual WhatsApp and Telegram group. So we're going to give room for interaction now, question and maybe answers before we call it a day. Thank you very much for listening. So by the grace of Almighty God, we're going to continue from where next time we move to precision agriculture, as the case may be. Thank you once again for listening. So we give room for interaction, question and answer. Thank you.